I'm Jennifer Lawler, Coordinator of Mathematics for the Kenosha Unified School District. I'm very proud to formally introduce to you the KUSD Fact Fluency Guidebook. This guide is a product of many hours of research, discussion, and debate by a dedicated group of KUSD elementary teachers. Let's start with what we know about computational fluency. First of all, we know that it's an important component of any elementary school mathematics program. We also know that many students fail to master their basic facts in elementary school. This often leads to a lifelong struggle in mathematics. Finally, we know that improving instruction and assessment of basic facts is our key to improving student outcomes in this area. The purpose of this guidebook is to provide teachers with essential background knowledge regarding the development of computational fluency and to establish a framework for basic fact instruction and assessment which attends to the development of all 5 strands of proficiency. These strands of mathematical proficiency come from the National Research Council's report, Adding It Up, Helping Children Learn Mathematics, which was published in 2001. This report was very influential in the creating of the Common Core standards for mathematics, so you will see many connections, particularly to the standards for mathematical practice. The strands of mathematical proficiency are conceptual understanding, procedural fluency, strategic competence, adaptive reasoning, and productive disposition. In this guidebook, as well as in this presentation, we will be focusing on 4 essential questions. First of all, we look at what is fluency? How does fluency develop? What can teachers do to help students develop fluency? And finally, how can we effectively assess students' fluency with basic facts? So what is fluency? Traditionally, we have defined fluency as simply fast and accurate. However, this definition, which again comes from Adding It Up, provides us with a much more nuanced definition of fluency. As you can see from this definition of number sense, when we talk about fluency, what we are really talking about is students' number sense, their fluidity and flexibility with numbers, a sense of what numbers mean, as well as that ability to perform math calculations. As elementary school educators, the best thing we can do for students to ensure their future success in mathematics is to ensure that they have number sense. As someone who taught at high school for many years, when students struggle in mathematics in high school, it's often because they don't have number sense. In grades K through 3, the Common Core standards place a great deal of emphasis on student fluency with basic facts. Notice that the standards make a very clear distinction between fluency and knowing facts from memory. They also emphasize the use of mental strategies before students are expected to attain mastery by knowing their facts from memory. It's also important to understand that knowing from memory does not equate to rote memorization. The best analogy that I've found is to think about when you sing a song along with a song on the radio. Now, this example here is from Wayne's World, which some of you may remember, but when you sing along to that song, it's not because you've memorized the lyrics, right? You didn't print them out and take them home and study them or put them on flashcards. You've heard the song on the radio many times, it's probably been stuck in your head, so you know the lyrics to that song from memory, even though you haven't memorized it. So how does fluency develop? This comes from research by Arthur Barodi, which was published in 2006, and it consists of 3 phases. First phase in fluency development are counting strategies. In this phase, students move from counting all to being able to count on or count back to solve problems. For multiplication, this means that students maybe skip counting. The more students work with numbers, they begin to develop more sophisticated reasoning strategies. They recognize patterns, they can use foundational facts like doubles or sums of 10, or other known facts to derive new facts. Students also develop an understanding of how the relationships between addition and subtraction and multiplication and division can help them determine unknown facts. Eventually, students' use of these reasoning strategies becomes so automatic that they just know certain facts. As students' fluency develops, students are likely to move between Phase 2 and Phase 3 as they add new strategies and more facts to their repertoire. The focus of classroom instruction should really be on Phase 2 and the development of reasoning strategies. If we rush students too quickly into Phase 3 by emphasizing rote memorization of facts over strategy development, students often revert to inefficient counting strategies when they encounter a fact that they cannot remember. So what can teachers do to help students develop fluency? Just like teachers model and teach reading comprehension strategies during literacy instruction, we need to teach and model computation strategies for students. Recall from the previous slide that students' reasoning strategies are the key to building lasting fluency. Research has identified two methods that are effective for helping students develop efficient strategies. The first one is called explicit strategy instruction. The other is guided invention. As the name suggests, the first approach involves explicitly teaching basic fact strategies that are applicable to a collection of facts. So the strategy lessons that are included in everyday math are an example of this type of strategy instruction. However, explicitly teaching strategies does not mean that students are required to memorize a strategy and the facts that will work with it. Rather, the intent is to support student thinking, not just give them something else to remember. So when you're working with students, remember, a strategy can't be wrong for basic facts. It's just maybe not the most efficient strategy. In addition, teachers can use purposely designed tasks and problems that will promote children's invention of effective strategies. This is referred to as guided invention. Regardless of which approach you decide to use, maybe a combination of the two, children will require multiple exposures to a strategy before they internalize it. Children also need practice in choosing strategies in a wide variety of settings, so it's important to provide them with frequent, meaningful practice. While students are in Phase 2, the best way to provide meaningful practice with basic facts are through games and number talks. Meaningful practice through games has always been an integral part of the Everyday Math program and should really be a part of every mathematics lesson. In addition to the games that Everyday Math provides us, there are some additional games that have been posted in every grade level binders that were compiled by teams of teachers from North Carolina. Number talks are also one of the most powerful vehicles for helping students develop number sense, while also showing the flexibility and creativity within mathematics. Who knew math was about being creative? There's more information and resources about number talks in the best practices section of your grade level curriculum live binder. As students begin to transition from Phase 2 into Phase 3, that happens in second grade for addition and subtraction, and at the end of third grade for multiplication, paired practice can be an effective method for helping students determine which facts in a group they just know and which ones they're still using strategies to figure out so that they can practice those facts some more. But it's important that students develop those strategies first before they start practicing to get faster at them. So how do we effectively assess fluency? So traditional approaches to basic fact instruction assessment that emphasize memorization of facts and rely heavily on drill and time tests really neglect the importance of flexibility with numbers and operations, as well as the importance of those other strands of proficiency in the development of fluency. Time tests, which is what we've historically used to assess fluency, really offer teachers little insight in how flexible their students are in their use of strategies, or even which strategies students are using. In addition, there's a lot of research that indicates that using time tests can contribute to the onset of early math anxiety for students, even high-achieving students. So the use of time tests and other speed-related materials also contributes to the myth that being good at math means being fast at math. So a lot of students who are really strong mathematical thinkers get discouraged and they develop math anxiety and they start to not like math and not think they're good at it. For these reasons, time tests are not included as part of this handbook and should not be used to assess mastery of basic facts. The forms of assessment that we encourage include observations, journaling, as well as interviews that can provide teachers with a more comprehensive and accurate picture of what students know, what they don't know, as well as their misconceptions. While students are developing strategies during Phase 2, assessment should be focused on determining which strategies students are able to use flexibly, as well as uncovering students' misconceptions. Once students have developed a strong repertoire of strategies and they're working towards mastery, meaning they're in Phase 3, mastery interviews are a productive way to assess which facts students have mastered. The tools for all of these assessment strategies are available in your grade level live binder. In addition to the assessment tools, quarterly expectations for fluency or mastery, depending on the grade level, have been established. These benchmarks are based on a logical progression of facts that begins with foundational facts and then connects each new set of facts to those that have been previously learned. The table on the slide here is a snapshot of these quarterly expectations. For a more detailed explanation of them, you can find that in your curriculum live binder. Students should be allowed to move through this fact progression at their own pace with additional support given to students who are not meeting those quarterly expectations, as well as enrichment opportunities for students who demonstrate mastery of all the facts before the end of the year. So after grade 3, there really is a shift in the standards on 3 different levels. First of all, there's a shift from really emphasizing basic facts to now working with multi-digit operations. There's also a shift from working exclusively with whole numbers to now also working with computation with fractions and decimals. And then finally, we see the shift from using strategies almost exclusively to paper and pencil algorithms. So despite these shifts, it's really important to remember that computational fluency is best built on a solid foundation of conceptual understanding. Number talks and games continue to be effective practices for helping students develop both mental math capacity and fluency with written algorithms. Just as we do not want to push students too quickly to mastery when they're developing fluency with basic facts, it's important for students to develop strategies for operations with multi-digit whole numbers, fractions, and decimals before they are taught the traditional algorithms. We also know that there will be some older students who have yet to master their basic facts. For these students, more drill is not a productive way for them to achieve mastery. Interventions for these students should focus on building computational strategies and helping them understand the relationships between the operations. There's some more suggestions for working on basic facts with older students in the guidebook itself, as well as in live binders. For teachers who are interested in learning more about strategy-based fact instruction and assessments, we'll be offering 2 courses this spring. Teachers who attend the course will receive a copy of the corresponding book, either Mastering the Basic Facts in Addition and Subtraction for kindergarten, first, and second grade teachers, or Mastering the Basic Facts in Multiplication and Division, which is particularly applicable to third grade teachers, but certainly open to fourth and fifth grade teachers also. These books are a phenomenal resource. They have a ton of information as well as an extensive collection of strategies and activities that you can take back and use in your classroom. So please watch the Spring Professional Development Catalog for more details.